So in this video, we are going to have a look at on how we are going to find the delta H value by using the energy cycle method. So I'll just use the same example that we did just now for the algebraic method, okay, where my target equation is 2 sulfur solid plus 3 moles of oxygen gas produce 2 moles of sulfur trioxide. Okay, so these two equation is our information given from the question because we already know this value of the delta H for this reaction. Okay, so actually it is easier to do the energy cycle method if you already did your algebraic method. Okay, why I said that? Okay, so let's have a recall on our algebraic method. Okay, so if you still remember, this is the equation that we already rearranged to form our overall equation that is the same with our target equation, so that we know delta to find the delta H3 is equals to the summation of delta H1 and delta H2. Okay, so now to convert it into the energy cycle method, okay, so this is our target equation. I'll just copy back our target equation: 2 moles of sulfur solid plus 3 moles of oxygen gas produce 2 moles of sulfur trioxide gas. So this one I'll just label it as same like my algebraic method just now, delta H3. Okay, so I need to find the value of the delta H3. Okay, so from here, okay, so I have 2 moles of sulfur solid, okay, and then in the first equation here, I do have 2 moles of sulfur solid, but then my sulfur solid here is reacted with 2 moles of oxygen gas. So I'll add the 2 moles of oxygen gas below below my sulfur solid. Okay, so 2 moles of sulfur solid plus 2 moles of oxygen gas will produce 2 moles of sulfur dioxide. 2 moles of sulfur dioxide gas. Okay, and then this is from the first equation. The second equation, I have 2 moles of sulfur dioxide plus with 1 moles of oxygen gas. So 2 moles of sulfur dioxide. Okay, I'll just add it with react it with 1 moles of oxygen gas. This one will give me 2 moles of sulfur trioxide. So this is my sulfur trioxide. So the addition of these two reactant will give me 2 moles of sulfur trioxide. So, and then I'll label the delta H, the enthalpy change for the first reaction, which is the delta H1, is equals to negative 594 kilojoules. And then here is my delta H2 for the second reaction, okay, which is negative 198 kilojoule. So by applying the Hess's law, again, the delta H3, the one that I want to find is, okay, the one that I want to find, the delta H3, okay, here, this is my delta H3, okay, is equals to, okay, if you look at the roots taken here, okay, this one is one step, okay, or the second step is I'll produce the sulfur dioxide first and then I convert it into sulfur trioxide. So here delta H3 is equals to delta H1 plus delta H2. Okay, so delta H1 plus delta H2. If you remember the definition of the Hess's law states that the enthalpy change, okay, is the same when reactant converted into product. The enthalpy change is the same whether the reaction takes one step, okay, this is the one step, or a series of steps. Okay, so here another route to produce the SO3 here is when I convert my reactant first into sulfur dioxide and then reacts it with the oxygen gas, then I produce the sulfur trioxide. So we have two steps here. So the enthalpy change is equals, okay, whether I take one step or a series of steps. So the delta H3 is equals to the summation of delta H1 and delta H2. And then you can substitute your value and then you will find the delta H3, okay, same answer like our algebraic method just now.